Functions are defined as integrals. Okay, which seems like a weird idea. You already know of one of them. Nobody's just ever showed you this before because you didn't know what an integral was. And it looks like this. So that means f of x is equal to integral from a to x of f of t dt. The function is defined as the area under a curve. Its value is given by the area under a curve. And the one that you have seen but has never been explained to you is everybody's favorite, the natural log function. Okay. The natural log function is defined. Now we would just say natural log of 4, natural log of 5, whatever. That's what we did in Math 12. We never talked about really what it was. Its definition is this. So what does that mean? It means the natural log is defined as the area under the curve of 1 over t, which I'll show you the graph in a sec here, from 1 to whatever x is. Okay? So the graph of 1 over t, 1 over x, whatever you want to call it, has a vertical asymptote at 0, right? There's 1. That's going to be our x. That area in red is the natural log. That area represents the natural log of whatever number. So when I say, or in Math 12, when we said, okay, what's the natural log of, I'll just say 2. That means the integral of from 1 to 2, 1 over t dt. Wait, where's my calculator? Natural log of 2 is 0.69. So it means on that graph, that area is 0.69. Now in Math 12, we just said, what's the natural log of 2? It's 0.69, it has a value. But that value represents the area between 1 and 2. Okay, under the graph of 1 over x. And you'll see when we do natural log derivatives next week, this will lead into what is the derivative of natural log of x? It's 1 over x. Okay? So, if a function, this isn't, like, it's great if you understand this, it's not crucial to this course. But because we can say a function is defined as an integral, we can take derivatives of functions. So now we're going to do the derivative of this, which is represented by an integral. And what do you know about integrals and derivatives? They're the opposite of each other, right? So, now we're going to do it the long way, and then I'll show you the shortcut, okay? Just so you understand where it's coming from. If we have the derivatives. So we have our function, f of x, defined as the integral from 0 to x cos t, sorry, not x. Now, forget that there's an f of x here. And if I just said, what is the antiderivative of cosine? You would tell me it's sine, right? And we would go, okay, it's sine of x evaluated between 0, it's sine of t. Why do I keep writing x? Sine of t, sorry. Evaluated from 0 to x. Everybody agree with that? Okay, we just did the antiderivative. Then we would plug in our x value and our and 0. So we would go sine of x minus sine of 0. Now I know sine of 0 is 0, but I'm gonna leave it as sine of 0 just to illustrate a point here, okay? So that's what the antiderivative of this is, okay? This is what our f of x represents. It represents the integral. We can find the antiderivative of that, evaluate it at these two endpoints, and we get this function. So this is f of x. Okay. What if I said, what's f prime? So that's f of x. What's f prime of x? Do the derivative. What's the derivative of sine? What's the derivative of sine of 0? Now think of sine of 0 as a number. It's a constant, right? Everybody agree with that? We know it's 0, but it's a constant. What's the derivative of any constant? 0. So that just goes away. So that's our derivative. Okay? Does anybody see the shortcut to go from here to here in one step? Sorry? Is everybody saying just put the x in there? That's right. Because they're canceling each other out, right? This is defined as an integral. We're taking the derivative with respect to x. So you just simply replace x in there. That's it. So if I gave you the question, call that one. If I said f of x is equal to, you know what? We'll do the natural log. Why do I keep writing this? The variable inside the integral has to be different than this. Okay. You're substituting that in. You can't have two x's there. All right. And then I said, okay, there's my function. And I said, what is f prime of x? You would tell me? It's 1 over x. This is actually the natural log. By definition, if you look up there, that's what the definition is, natural log. So you've just shown me that, now we'll talk more about this next week, that the derivative with respect to x of the natural log of x is equal to 1 over x. Don't worry about writing that down. Okay? That's what we're going to start doing next week. All right? And this is why. Because it looks weird. What's the derivative of natural log? And you get this. And you're like, well, where does 1 over x come from? All right? It's because the function is defined as the integral from 1 to x of 1 over t. And so when you take the derivative of that, the integral goes away and that x gets subbed in. Now, there's always a wrinkle. Nothing in calculus is going to be this simple, all right, except for these questions. What if I gave you this? And this is how it would be written. Well, it doesn't have to be written. That is a 7. It can be any constant you want. It doesn't matter. Make it 4. Make it pi. Make it e. Make it e to the I pi or something. I don't know. Okay. So we're doing the derivative of an integral. Okay. But what's the difference between this one and all the other ones we've done? This is not x. 3x squared minus 5. Polynomial. Okay. This is still a constant, so that's good. So I'm going to show you the long way, and then we'll show you the short way, okay? The long way is this and this are the same. So I know the antiderivative is sine of x. evaluated from 7 to 3x squared minus x. And then what do? You sub both of them in and subtract, right? So I sub them in, and I get sine so I've got that. That's my function. I shouldn't have written it like this, but whatever. So you know what I should write in here, just for proper notation? Because we are doing derivatives here. Okay. So now we're going to do the derivative of that. If I do the derivative of the first part, this bit right here, what rule do I need to use? Chain rule. What's the derivative of sine? Cosine 3x squared minus x times what? 6x minus 1. What's the derivative of sine 7? 0. Because sine 7 is a constant, derivative of a constant is 0. So that just goes away. So this is my answer. How do I go from there to there in one step without doing that middle step? Yep. That's it. So when this is not an x, it does get subbed in. That gives you this bit. But you need to remember to multiply by the derivative of this. Chain rule still applies. All right? So then it just becomes times 6x minus 1. So now if I gave you a question like, let's do the natural log one again. I'll just keep coming back to that. X squared plus 3x of okay. What is the answer? Sub in that. Multiply by 2x plus 3, the derivative of that. And that's it. And what you just did is what we're going to learn next week. The derivative, you don't need to write this down. Because you're going to see next week that, especially when you do the natural log, because this is essentially the natural log, the derivative of the natural log is 1 over u times u prime. This is my u. 1 over that times u prime, which is the derivative of that. So this is where the derivative of the natural log comes from. It's u primed over u. Okay? Page 290, 81 to 91, odd. Number 87 will be fun. You just got to think a little bit about that. There's only like 20 minutes left, so